that you are responsible for and you're going to have to know how to graph. And that is the oblique asymptote. The word oblique, sometimes in some books they use the word slant. And notice what it is a line, and it's of the form y equals mx plus b. So it's a regular old line. And the graphs come in two flavors. What happens is that the VA forms a vertical line. The OA has a slanted line. And what you get from the two asymptotes form an X. And the graph is either inside the X or outside the X. Say here would be your VA. There would be your OA. It forms an X. Here the graph is inside the X. It forces a shape. And here the graph is outside the X. So once you have the X, it's either inside or outside. That's your OA. They're always that way, one or the other. Very predictable graphs. Once you know exactly where it's at, then you can find it. The other one, I call just plain other. And it can be of the form any polynomial degree 3 or 2 or higher. Degree 2 or higher. This is an asymptote of degree 2. And what I want you to notice is this. Here is the problem right here. I did a vertical shrink factor of 0.1 in order to get this graph to look the way it does. I notice that it has a VA at x equal 2 because x can't be 2, so the VA is at x equal 2. And we'll talk about how you find the end behavior. The end behavior asymptote is 0.1 times x squared plus 2x plus 4. So what you see is the dotted line is the asymptote. And if I look at the outside of the graph, if I didn't know what was happening on the inside, it looks like that parabola on the outside. Inside it does other stuff, but on the outside it looks like the parabola. Here's a cubic, and notice there's an S-curve. If I cover up the inside, see if I can do that. The outside shapes becomes part of the S-curve. The inside does all kinds of stuff, don't care, because this is all as x goes to infinity or minus infinity. It's what happens at the end. It becomes part of the asymptote. It shapes out the graph in the end. But you're responsible for OAs and HAs. Those are the ones I'm going to expect you to graph.